So let's talk about something called free fall. Free fall. So free fall is when gravity is the only force, significant force you could say, and air resistance must be therefore negligible or not even there. So we kind of ignore air resistance at this point. Now, free fall doesn't just mean it's falling in the sky, but when you throw an object up in the sky, it is also in free fall. Also, when it's like stops at the maximum height, it's in free fall. When it's traveling down, it is free fall. Now, we take gravity as 9.81 meters per second. So that means every second it increases in speed by 9.81. It doesn't mean it will travel 9.81 meters per second. It just means its velocity is changing by that much. So it's 9.81 meters per second squared. So regardless of the mass, you're going to fall with the same acceleration. Weight is equal to mass times by gravity. Now, in Newton's second law, it looks very similar to this, where this is our acceleration, this is our mass, and this is our force. Now, if gravity is the only force, what we can say is mass times acceleration is mass times gravity. So we got something like that, and we could divide both sides by m. So we could say A is equal to G. So you could just see acceleration depends on gravity. It does not depend on the mass of the object. But obviously, a higher mass object will produce a higher force. So let's look at this. Let's say you're traveling upwards, okay? And let's just say that upwards, the velocity is positive. Now, the acceleration is in the opposite direction. It's pointing towards the Earth. So it is going to actually be negative. So velocity positive, acceleration negative. And what does that mean for the actual speed? Well, if you got positive velocity, but you're accelerating downwards, your velocity is actually going to be decreasing. Your speed is actually decreasing. What about if I travel upwards and I reach a maximum height over there? There, I will stop moving before I move downwards. So my velocity will be 0 and my acceleration is a negative, and my instantaneous speed is going to be 0. When I travel downwards, my velocity now is negative because I am traveling downwards, and my acceleration is still negative. So when you reach the highest point, so if I'm traveling upwards and I reach the highest point over there, my velocity is going to be 0, but my acceleration is not 0. My acceleration is still 9.81 negative. So the velocity is only 0 for 1 instant. Gravity continues to accelerate the ball downwards, causing the velocity to become negative afterwards. So when it travels downwards, the velocity is now going to be negative. So some people make this mistake. They think that the velocity and acceleration are 0 when you reach the maximum point. But what you actually say is at the highest point, the instantaneous, so at the instant, the velocity is 0, but the acceleration is still g, which is gravity downwards. So this is example number 1. Here they say calculate the maximum height above a point. So at the maximum height, we know the velocity is going to be 0, but it's traveling initially at 14 meters per second. And we know what the acceleration is. The acceleration is downwards, is 9.81. So what they're looking for is S. So everything with what we need is actually this equation over there. We just have to substitute our values in. So we get something that looks like this. So we get this at the end. We move the 19.62 S on the other side, which is equal to 106. And then we've got S is 196 divided by 19.62. So S ends up being 9.99 meters, which means S is 10 meters approximately. Then they say, what is the time to reach this maximum height? We could use this equation right over there. So 0 is equal to initial velocity minus 9.81 times by t. So T, if you rearrange it, move it to the other side, is 14 divided by 9.81, which is 1.43 seconds. Then they say, what is the total time? So without air resistance, the upward and downward parts are going to be symmetrical. So you just double this again, and you get 2.85 seconds. And that is going to be my answer. So one thing I want to talk about is what if you drop an object from rest? Now, if you drop an object from rest, all that means is that U is going to be equal to 0. So you could actually eliminate all of the U's in these equations. So what we could say is V equals AT, but we say V, what is the acceleration, is GT. We could say S is equal to, this is for constant accelerations. I mean, this is for 0 acceleration, so we won't use this one. This one, these all have acceleration, so we could say half GT squared, because that's what the A is, and then V squared equals 2GS, like so. Now, I'm going to do this again. A small ball is dropped from rest. So U equals that. Vertical distance is 30. Ignore air resistance. So what we're going to use is acceleration is 9.81 because it's due to gravity. So what we got is we're looking for T. Okay. So we got S. We got U, we don't need this UT. We got half, we got the acceleration. We're just looking for the T. So we could use that equation. We could write it like so. We could write T squared is equal to 30 divided by half times by that, which is 4.90. So T is the square root of all of this, which ends up equaling 2.47. We can also find out what final speed is. Final speed is acceleration times by the time, which we just work out, and it's 24.3 meters per second. Now, what about if we did have some air resistance? So if we had some air resistance, what we could find out is the resultant force, which will be the weight of the object, so mass times gravity, minus the air resistance. So this is what we call air resistance. Now, from Newton's second law, we know force is equal to mass times acceleration. So I could rewrite this equation and I could divide everything by the mass. So acceleration is equal to just gravity minus the air resistance divided by the mass. Now, for an object to speed up, what we are going to say is that the weight of the object, so mass times gravity, okay, is going to be greater than the mass times by gravity minus the drag coefficient. Terminal velocity, what you're going to get is you're going to get the air resistance is going to equal the weight of the person. So hopefully this helped you understand the topic of free fall. Have a nice day. Take care.